My plan for this homework video guide is to cover the homework questions from section 1.2 on greatest common factors and least common multiples. So for question number 3, this is where I'll start. The number, we're given this number here, it's pretty big. It's 36,890 something, and it has a missing last digit. So I don't know what this last digit is, and we need to find the smallest digit so that the number is divisible by 2. Okay, so once again, we're given this pretty big number, 36,890 something. Our goal is to find out what the last number has to be such that it's divisible by 2 and it's small as possible. Okay, now the rule is if you're divisible by 2, the last digit must be 0, 2, 4, 6, or 8. Okay, so out of those digits, which one's the smallest? Well, I think 0 is the smallest, so if I plug in 0 over here for my last digit here, that would make this number right here, 36,890. That's definitely divisible by 2 because the last digit is 0, and the last digit is small as possible. So the answer here is going to be 0. Okay, so same problem. Now the number has to be divisible by 3, and the number has to be as small as possible. Okay, so the rule is if you want to figure out if a number is divisible by 3, the sum of its digits must be divisible by 3. Okay, so when we say sum means we need to add. All right, so what are the digits that we have right now? I have a 3, I have a 6, I have an 8, and I have a 9. If I add those 4 digits, I get 26, right? Now ask yourself, what do you have to do to 26 to make it divisible by 3? Okay, well, if I add 1 to it, it becomes 27. Is 27 divisible by 3? It sure is. So what we need to do is we need to add 1, or we need to make the last digit here 1. And if the last digit is 1, basically what's happening now is you add up all the digits, which that now gives you 27. And since 27 is divisible by 3, that means this entire number is divisible by 3. And 1 is a pretty small number, it's as small as possible, so the answer here is going to be 1. Okay, so for this first exercise, your goal once again is to find what the last digit can be such that it satisfies the condition, and we want that digit to be as small as possible. All right, so next one here, we want to make sure that our number is now divisible by 4, and it has to be as small as possible. Okay, so the rule for a number to be divisible by 4 is that the last 2 digits are divisible by 4. The last 2 digits are divisible by 4. Okay, so let's take a look at the last 2 digits here. There's a 9 and something that we don't know yet, right? So if I look at the 9 here, maybe the next digit could be maybe a 0. Now ask yourself, if this was 0, is 90 divisible by 4? Is 90 divided by 4, does that give you a nice integer? And the answer is no, that's about 22.5, so the last number cannot be 0. Okay, what's the next number after 0? Well, the next number after 0 is a 1, right? So ask yourself, is 91 divisible by 4? So if you go to your calculator and if you type in 91 divided by 4, I still get a decimal answer, so 1 does not work. Okay, let's try 2 now. Is 92 divisible by 4? And the answer is yes, 92 is divisible by 4. That gives you 23, which is an integer. So the smallest number has to be 2. Okay, so for a number to be divisible by 4, the last 2 digits must be divisible by 4. Okay, let's move on to the next one here. Okay, so now our number has to be divisible by 5 and has to be as small as possible. Okay, so the rule for a number to be divisible by 5 is that the last digit must be 0 or 5. So this one's kind of easy because which one's smaller? Is it 0 or is it 5? Well, it's definitely 0, so the last digit has to be 0 here. Great. Now let's move on to the next one here. Our number now has to be divisible by 6, and it has to be as small as possible. So basically the rule for a number to be divisible by 6 is that it has to be an even number that's divisible by 3. Okay, so if you're an even number, that means the last digit has to be 0, 2, 4, 6, or 8. Okay, And then what we need to do now is, okay, so let's just put in our options here. So we have 0, we have 2, we have 4, we have 6, or we have 8. Okay, then the next rule is that it has to be divisible by 3. Okay, so what does that mean? If you're divisible by 3, we already established that the sum of the digits have to be divisible by 3. Okay, so let's just pretend our answer is 0. Okay, so now the question is all of this divisible by 3? Well, what we can do is we can add up the digits. So 3 plus 6 plus 8 plus 9. I know that's going to be equal to 26. And then if I add this 0 here, that still gives me 26. Is 26 divisible by 3? And the answer is no, right? So the last number cannot be 0. What happens if I plug in the number 2 there? Okay, if I plug in 2 there, then I just need to add 2 to this number here. So 26 plus 2 is going to be 28. Is 28 divisible by 3? That's a no. So that means this digit can't be 2. All right, let's try 4 now. Okay, and I believe this is going to work because if I have 3, 6, 8, and 9, that equals to 26. If I add 4 to that, that gives me 30, and 30 is definitely divisible by 3. Okay, so the last number here should be a 4. All right, and the reason why the last number, the last digit there is a 4 is because if you have 4, it's definitely an even number. All right, and if I add up all these digits, 3 plus 6 plus 8 plus 9 plus 4, I get 30, and 30 is divisible by 3. And that's how you do that question there. Okay, let's do the last one here. Now we have to find the last number such that the overall number is divisible by 9, and once again we want to make sure it's small as possible. Okay, so for a number to be divisible by 9, the sum of the digits are divisible by 9. Okay, so very similar to a number being divisible by 3, we have to add up all the numbers. Okay, so right now we have 3 plus 6 plus 8 plus 9, that gives you 26. So what do you have to do to 26 so that is divisible by 9? All right, well, let's just add one more to it. All right, if I add 1 to it, it becomes 27, and 27 is definitely divisible by 9 because 27 divided by 9 is 3. So this will be my last number here, which is a 1. Okay. And once again, if the last digit is 1, if you add up all those digits, you get a number that is divisible by 9, and that's why we have satisfied the condition there. So the last number is going to be 1 for this case. Okay, let's move on to the next question in the homework guide here, which is question number 6, I believe, and determine whether the number is prime or if it's composite. If the number is composite, factor it into primes. Okay. For 6a, the number 19, I can't think of any numbers that multiply to 19 except for 1 and itself, 1 and 19, so this is definitely a prime number. For 87, is there a number that divides 87? Well, I'm not sure, but what happens if we use some of our strategies? For example, what happens if I add 8 plus 7? Well, 8 plus 7 is 15. And 15 is divisible by 3, right? That's one of the rules. So I know that 3 goes into 87. So if I find a number greater than 1 that divides the number, it's a composite number, right? So this one's a composite number. And then let's go ahead and figure out, factor this into its primes. So I just established that I can definitely divide 87 by 3. All right, so what's 87 divided by 3? That's going to be 29, I believe. Okay, so what we've just established is that 87 is equal to 3 times 29. And once again, 3 and 29 are prime numbers. And that's it for letter C. Okay, let's move on to letter E, 117. Okay, so I'm not sure what number will divide 117 nicely. So if I use some of my strategies like adding up the digits, 1 plus 1 plus 7, that gives me 8, 9, so 9. Now 9 is divisible by 3, so I know that 3 will divide into 117 nicely. All right, so if I do that, I get 39. And what number divides 39? Well, I believe 3 divides 39, and then I get 13 there. So what I see here are my prime numbers, 3, 3, and 13. So what I've just established is that 117 is equal to 3 times 3 times 13. And these are basically the blue numbers there. Okay, so that's what it means to factor the problem into its primes. So 3, 3, and 13 are prime numbers. Okay, let's move on to the next one here. 611. Okay, for this one I can't use any little tricks here, and I kind of did this question in advance, and I know that 13 will divide into 611, and that happens 47 times. So this one's kind of like a calculator type problem. So what I've just established is that 611 is the same thing as 13 times 47, and both 13 and 47 are prime numbers. Okay, so that's it for question number 6. Let's move on to question number 7. Simplify using prime factorization. Okay, so this is how we're going to solve this problem here. We're going to take the numerator, which is 385, and we're going to break this down into prime numbers here. Okay, so what number divides into 385 nicely? Well, the number I'm thinking of is probably the number 5, and that's because the last digit number here is 5. Okay, so what is 385 divided by 5? Well, that's going to be 77. Okay, and then can you think of a number that divides into 77? I'm thinking about 11, and 77 divided by 11 is going to be 7. And as you can see, these are all prime numbers. And once you have all prime numbers, you can stop. So 385 is the same thing as 5 times 11 times 7. So all these numbers are now going up here. Okay, great. Okay, now let's take a look at the bottom number, which is 455. And I can see that the last digit here is a 5, so I know that this is definitely going to be divisible by 5 here. So 455 divided by 5 is going to be 91. All right, and then what number divides into 91? The number 7 divides into 91, and then you get 13. So 91 divided by 7 is 13. And as you can see, 5, 7, and 13, these are all prime numbers. So I will now write 5 times 7 times 13. So those numbers go there on the bottom. Okay, so we have all these prime numbers here, and as you can see here, I have a 7 and a 7. So basically those will now cancel off. And we also have a 5 and a 5, and those will cancel off. And that means I have 11 on the top and 13 on the bottom. So 11 over 13 is the final answer there. Okay, let's move on to question 7b.